Hey guys, hope you guys are all doing okay. So today we've got this, and what you may recall if you've been listening to some of my other videos is that I'm helping a mate of mine who is building a remote control RC helicopter like the AirWolf, the popular 80s program called AirWolf, and it had these guns on the side that came out like this. And that's what we're trying to do here. So he's built this up, he's fabricated this design, and my task was to get all the electronics working. So really what this video is about, but I'm going to walk you through the mechanics of how it works too, because there might be someone out there that's interested. All I've got over here, guys, I've got a Radio Master TX16. I've just put it on a switch, so when I flick the switch it comes out, and then when I flick it back again it goes back in. That's all you've got over here. It's transmitting over here to this FreeSky receiver. It's an XR, sorry, it's an X4R, I think is the real name for that. X4R SB. Feeding down here onto this power bus bar. This is just a 6 volts, running on 6 volts. 6 volts bus bar, and obviously I've got tapped some signal wires off there too. So that keeps disconnecting for some strange reason. Doesn't normally disconnect. Let's come back, and it goes up this yellow wire here onto this ESP32, just a standard smaller variety. They were 30 pin ESP32s. Everything on the left side of the ESP32s to control this left hand cell, which is what this is, and then that leaves the right side for the right hand cell. A couple of other taps here because you've got Hall effect sensors actually on the cell, so the ESP32 can work out where it is. Let's just take that main camera down a little bit. That might look better. You get a better picture. So let's see what we've got. So if we keep this up, so this is the right way up at the moment. We've got a Hall effect sensor here, so this bit goes in here, slides across to bring the cell out on this side, and this is a Hall effect sensor. There's a little magnet there, so that allows me. It doesn't do any controlling of the stopping and starting. It just tells the microcontroller that the actual cell is in the out position or in the in position. There is another magnet and Hall effect sensor in there. If you can see that in there, we'll show that when we get the cell open. Let's open the cell. So in there is another Hall effect sensor, and the magnet is built into this part here, into the front edge, and that can tell me that the cell's actually closed, and that's really to ensure that these guns don't come out and foul the side of this fuselage, as this has got to slide in. This will slide into the helicopter itself. That's what that's doing. This LED goes out once it's back in, and you might just have seen then on the video if it wasn't too quick that it actually goes out before it goes in, so you don't get any sort of blue flare once it's in here. And again, when it comes out, it wants to just pass slightly before it actually comes on, just for the aesthetics. So that's what these two do. So they're nothing about controlling the movement, because this is just a standard servo here. A normal servo does not sort of 90 degrees, so we can program that one quite easy. It's a little bit more complicated when we come over to this one here, because this is the 360 degree servo that sends the guns out. So let's flip this over so it's upside down, and we can see now this 360 motor here, and we can see that when we flick the switch, it spins around. What it's actually doing is it's taking a wire tie here, and this wire tie sits in here. If we take this little part around here, we slide that down 90 degrees, then this will actually open up. Part will open up, and we see that all we've got is a wire tie here going down through this rod and then through into the guns, and that spinning, that 360-degree servo spinning, pushes the wire tie through, which ultimately pushes the guns out at the other side. And this is controlled now. This is version 2. The first one was controlled by counting these magnets on the top, using this again the same sort of thing as the Hall effect sensors. And you'd have to go around sort of 3.5 times in and out. But that was a little bit complicated, if I'm honest. I think this design is better that Chris has put together. So Chris has designed this one, so he's got Hall effect sensors. Now, forgive me because I don't know where they are, but he's got Hall effect sensors that tell me when he wants me to stop the guns on either when they're retracted or extended. So all I've literally got to do is watch out for those Hall effect sensors, seeing the magnets, and turn this 360 motor off, because this motor would just go on forever. That's the thing about a 360-degree motor. They would just, when you alter the signal to turn clockwise, it will just continue to turn clockwise, and you centralize the signal for it to stop. A 1000 microsecond pulse will make it go either anti-clockwise or clockwise. There's no standard. A 1500 microsecond pulse will centralize it and stop it from spinning. Then a 2000 microsecond pulse will make it go the opposite way, either clockwise or anti-clockwise. And that's how we control that. You can see here better when we actually send the cell out. It does wobble. Well, let me see if I can get that looking and hold it down so you can see it better. Quite a little ingenious mechanism. So looking at the ESP32, let's have a look at the code that we've got to use, and if anybody wanted to have a look at the code, where they can get it from. So this is the GitHub repository that you might want to look at. And what it does, if we go in there, you'll find that we've got the wiring diagram at the bottom, a little bit of bump. We've still got the rocket launchers to add, so thus we've still got some spare ports on our ESP32. This is the wiring diagram that will eventually be used should anybody want to look at the code. And the codes here, it's pretty easy to read, I guess. Really, you've got some things you can alter here. This controls, and again, it's all part of the documentation here. There's not lots of documentation, but it tells you a little bit of here how to set the activation zone for the RX, setting up the sort of parameters here should anybody want to try to use this code. But obviously there's more to come. Chris has got to build a second nacelle, I think they call them, and when he's done that, well, then we can get both of them working together, and hopefully I'll get a video at the end showing at least the end product, and hopefully get some footage of it flying with the guns coming out while it's in the air, etc. So more videos to come. He wants me to show him how to design a tire. He's got this one here, but this is more of a plain sort of tire. Can we see that bottom corner? Will it focus in? I think we can probably just about see that. So this tread pattern doesn't really want that kind of pattern on there. So hopefully I can show him how to do that. So there'll be different videos coming up. It's a little bit strange for my channel, but it's all about learning, and that's what my channel is all about. So I hope that was useful, guys. Please do what the sign says. Get it right one day. Like and subscribe, and I'll see you on the next one.